Hello everyone, welcome to my channel and welcome to another video on integration. If you're new to this channel, don't forget to subscribe, share these videos with friends, invite friends to subscribe. It will help us grow the channel and give us the ability to generate many more videos and support as many students as we possibly can. So our first integral in this video is the integral of x times the square root of 2x plus 1 dx. Now how we approach this is when you look at the expression under the square sign, it's 2x plus 1. Differentiating that, it gives you 2, but there's x outside, which means this is an advanced form of u-substitution. So we approach it as follows. Integral number 1, it's the integral of x times the square root of 2x plus 1 dx. Like I said, we're going to let u squared be equal to 2x plus 1. Why u squared? Because the square root sign there. So we have to obtain 3 equations from this one. The first one is take the positive square root both sides. You're going to get u being equal to the square root of 2x plus 1. And yes, this can also be written as 2x plus 1 to the power half. That's the meaning of square root. Now, the second equation we're going to obtain from there is solving for x, because we have x outside here. Making x subject formula here, you'll agree with me that we have u squared minus 1. This is equal to 2x, and then divide both sides by 2. Basically subtract 1 from both sides, you get this. Divide both sides by 2, you're going to get u squared minus 1 all over 2, and that is equal to x. Right. The third equation we're obtaining from there is the implicit differentiation. We differentiate both sides. We're going to get 2u du. On the right hand side, you'll agree with me that we're going to get 2 dx, because derivative of 1 is 0, 1 being a constant. But if you look at this part here, we have dx, so we have to solve for dx here. In other words, divide both sides by 2, you're going to get u du is equal to dx. Now we are okay, we're good to go now, because that part can be replaced by u du. And under the square sign, I'm going to put u squared, and outside there I'm going to put this expression here. Taking us to page 2 and transforming this integral, what we get is the following. Right, let me move this one down so we can actually clearly see what's going on there. Right, so now what I have is that integral now can be transformed as the integral of, watch this, u squared minus 1. Allow me to put this in brackets all over 2, that's representing x, and we're going to say times square root of u squared, and outside here we're going to have u du representing dx. Taking half outside, because half is a constant. Remember what I said. What I said is that part will be replaced by this expression, like that. And under the square sign, I'm going to put u squared, like that. In the place of dx, I'm going to put u du, like that. Right. Take half out because it's a constant. And we have the integral of u squared minus 1 in brackets. And this cancels that. Remember, we're talking about the positive square root there. We have u times u du, and u times u is u squared. Keeping half outside, we have u squared minus 1, and outside we have u squared du. Distributing u squared, we have half outside, the integral of u to the power 4 minus u squared, and then we have du outside. Distributing the integral and du, keeping half out, we have the following. We have the following here. You keep this one like this there. So what do we have now? What we have now is, this is going to be half. Allow me to use brackets out now. It will be the integral of u power 4 du minus the integral of u squared du, like that. Evaluating these two integrals, we have half outside, and we have u to the power 5 over 5 Remember, you add 1 and then divide by the result that you obtained. And then we have the same here, add 1, it's going to be u power 3, divide by 3, and then we have c, because this is an indefinite integral. We distribute half, taking us to page 3. Distribute half and moving back to our original variable. So what we have now is distributing the half. We have that being equal to 1 over 10 u power 5 minus 1 over 6 u power 3 plus c. That's what we have. Now we must get rid of u, go back to our original variable, which is x, and that's why we had to solve for x. We had to solve for u here. This expression is what must take the place of u, which is 2x plus 1 to the power half. So now I have this changes to 1 over 10, and then I have 2x plus 1 power half, but we have to the power 5 outside, and then we have minus there 1 over 6, and then we have the same thing, 2x plus 1 power half, outside there's a power of 3, you can see the power of 3 there, and then plus c. Hopefully you can see the 3 there. Right, now rewriting this and simplifying, getting us to our final step, it's 1 over 10, and then we have 2x plus 1. Remember laws of exponents, the power half inside and power 5 outside, the two must multiply. So we get 5 over 2, and then we have minus 1 over 6, and then we have 2x plus 1. Again, the power inside is half, outside is 3, so we have 3 over 2, and then we have plus c. This is our final solution to integral number 1. Right, we're moving on to integral number 2. Integral number 2 in this video is this one here. Let me put this aside. Our second integral is this one. That's the second integral right there. How do we approach it? Well, if you look at the denominator, we have e to the power x minus 1. Now, if you differentiate the denominator, it gives you e to the power x. We don't have e to the power x in the numerator. Again, another case of advanced u substitution. We must do something. We have to introduce e to the power x in the numerator. So, integral number 2, it's the integral of dx all over e to the power x minus 1. Like I said, we're going to have to introduce e to the power x in the numerator and the denominator because we don't want to change the integral. So this will be the integral of e to the power x dx all over e to the power x times e to the power x minus 1. Notice these two can cancel. You are back to the original integral. But we're not going to cancel that because we want to now use u substitution. But let me rewrite this first. So this is equal to the integral of 1 all over e to the power x times e to the power x minus 1, and then we're going to say multiply this by e to the power x dx. I'm combining these two because of the following. Now we're going to let u be equal to e to the power x minus 1, this expression there. So clearly from here you can see that what we need to do now is to obtain those famous equations. The first one will be to solve for e power x because we have e power x here. Now solving for e power x, you'll agree with me, we are going to have u plus 1 is equal to e power x. Add 1 on both sides. This is what you're going to get. The second one will be to differentiate on both sides with respect to x. Differentiating here, it's going to be du. I can just take dx on the other side. It's going to be e to the power x dx. Now you can see this one is that one there. So that part I'm going to have du. In this place here, I'm going to have u, and there I'm going to have u plus 1. So that integral is transformed as follows, taking us to page 5. What we have now is the following. Right, what we have now is the following. We're basically saying, yeah, you can see what I want to talk about. Let me move this one further down. Right. Okay, so now I'm saying that integral is transformed as follows. It will be the integral of 1 all over, in the place of e power x, I'm going to have u plus 1. U plus 1. In the place of e power x minus 1, I'm going to have u. Then times in the place of e power x dx, I'm going to have du. Right, now we can go ahead and see how to move from there. Let me move this up now. So our approach now is going to be, let me rewrite this. It's going to be the integral of 1 all over. Let me start with u and then u plus 1 du. This part here, we have to use partial fractions to decompose this part here as follows. 1 over u plus 1. We have two linear terms here, u and u plus 1, can be written as a over u plus b over u plus 1. LCD, lowest common denominator on the right hand side, it's just a product of the two denominators, u times u plus 1. U into this expression here, it will be u plus 1 multiplied by a, so it will be a times u plus 1 plus that plus sign there, and then this expression into the denominator, the answer is u times b. You agree with me, the answer is bu. On the left you have 1 all over u plus 1. Right, now we have two fractions here which are equal, and denominators are also equal, therefore numerators must be equal. So I'm going to say this here equals 1. So, and expand this part, it's going to be a plus bu is equal to 1. That expression equals that. Now, let me rewrite here. I'm going to have a plus b, and I'm factorizing that, plus a, this part and that part, plus a, that constant term, that one there, is equal to, watch how I'm going to rewrite this, 0u plus 1. Because we don't have u there, so it means the coefficient of u is 0. Equating coefficients, this part equals that part. I'm going to say a plus b is equal to 0, and the other expression is a equals 1. Constant term equals 1. And bringing that one to the left, you're going to have 1 plus b equals 0. You'll agree with me that b equals minus 1. So the two expressions, b equals minus 1 and a equals 1, are critical because they allow us to change this integral into, in place of that, we're going to have 1 over, because a is 1, 1 over u, and then I'm going to have minus 1 over u plus 1. All right, as follows. So we're now saying, let me move this one down. That integral there, this integral now changes. That place, the integrand would have to be replaced by this expression with the constants a and b as being equal to 1 and minus 1 respectively, as follows. So basically we're now saying that integral is equal to 1 over u, allow me to say plus, minus 1 over u plus 1 du. Watch what I'm saying here now. This part here has been replaced by that expression because these two expressions are the same, but a is 1. So I put 1 there and b is minus 1. I put minus 1 here, as follows, or like this. Now let's distribute the integral and du. What we have is the integral of 1 over u du. That minus sign will change that sign to minus. The integral of 1 over u plus 1 du. Evaluating this, you'll agree with me that the answer here is just natural log of u minus, this will be natural log of u plus 1. Now we must say plus c because we're dealing with an indefinite integral here. Now, what is u? Well, remember we said u is e to the power x minus 1. So where there's u, I put e power x minus 1. So this is going to be natural log of e to the power x minus 1 minus natural log of e power x minus 1, but there's a plus 1 here, plus 1 plus c. And our final step is going to be natural log of e power x minus 1. Okay, final but 1. Okay, so this is going to be minus natural log of Notice I don't need the absolute value now. It's just e power x plus c, and natural log of e power x is just x. Remember properties of logs. So the final solution therefore is going to be as follows. Our final solution is going to be natural log of e power x minus 1 and then minus x plus c. That's our final solution to integral number 2. Right. Please, at your own time, stop these videos, work out these integrals, and come back and check the answers and see if we are obtaining the same solutions. This is integral number 2. I have 15 minutes. Hopefully, I can manage to go through the third integral in this video. Here is the third integral. It's the integral of e to the power 2x all over cube root of 1 plus e power x dx. I hope I can work this one as quickly as I can. Manage to finish it in 3 minutes or 4. So again here, if you look at this, is cube root, and we have 1 plus e power x. Differentiating this, it's going to be e power x, but we have e power 2x there, which means we need to do something. Again, another case of advanced u substitution. Our last page was page 6. Let me move to page 7 here. So we are now saying integral number 3. It's the integral of e power 2x all over cube root of 1 plus e power x dx. Now, because of cube root there, I have to say, first let me transform the integral. So this will be e power x all over, watch this, cube root of 1 plus e power x, and I'm going to say here times e power x dx. Notice these two coming from e power 2x, these two will give you that if you multiply them. Powers must add to give you that. The reason I'm splitting them is because I want to say now, let u cubed be equal to 1 plus e power x. Again, we're going to obtain 3 equations from here. The first one is take cube root both sides. You get u equals cube root of 1 plus e power x. That's the first equation. And again, you remember this is the same as 1 plus e power x to the power 1 over 3. Don't forget that. That's cube root. The second one will be solving for e power x, because we have e power x in the numerator. That will be u cubed minus 1 is equal to e power x. Make u subtract 1 from both sides to get this. The third one will be differentiation implicitly on both sides. So it's 3u squared du on the right hand side is going to be equal to e power x dx. Derivative of 1 is 0 because 1 is a constant. Now this part is that part, as you can see. So we're going to have this replaced by that, and the denominator will be cube root of u cubed. In the numerator, I'm going to have u cubed minus 1 as follows. Page 8 now. So what do we have now? We have this integral changing to, I'm going to do this, the integral of u cubed minus 1 in the numerator. I'm going to say all over cube root of u cubed, and there I'm going to have 3u squared du. Remember what I told you. The numerator will be u cubed minus 1, like this. The denominator will be cube root of u cubed there, like that. And then e power x dx, it will be 3u squared du, like that. Take 3 out because a constant. You're going to have 3, the integral of u cubed minus 1. Let me put this in brackets all over. This cancels that. It's going to be u times 3. The 3 must go because I've taken it to the left hand side. Let me get rid of it from here. Let me get rid of it very quickly here. And I'm going to say that expression there multiplied by u squared du. Now this cancels 1u. So what do we have now? We have 3 integral of u cubed minus 1, and then we have u du. Distribute u and du and the integral sign, keeping 3 outside. three things at the same time. The integral of u cubed. Okay, I have to distribute that, so it has to be u power 4. Yeah, okay, I'm gonna do this times u minus 1 times u. Let me keep this in brackets like that, du like that. Remember, we're distributing u there and here. What do we do in the next step? I'm going to keep the 3 outside, and then I'm going to say the integral of, remember this is u power 4, and I'm going to have to say du minus the integral of u du, like so. Distribute this and that. This is u power 4, and that's just u. Evaluating these two integrals, we get page 9 as quickly as possible. Page 9, what do we have? I'm going to bring the 3 down here, and I'm going to say what we have is, let me move this one down. All right, so page 9, we're going to see that is just the same as 3. Keep that outside. Evaluate this, u power 5 over 5, and then minus u squared over 2. Don't forget to say plus c, because this is an indefinite integral. Distribute the 3, you're going to have 3 over 5, u power 5 minus 3 over 2, u squared plus c. Let's put in what we know. What is the expression for u? The expression for u, if I may find it on the other page here. This is page, here we go, page 7, because this was page 8. Yeah, page 7. Here's the expression for u. It's 1 plus e power x to the power 1 over 3. In other words, cube root of that. So I'm saying this is 3 over 5, and then I have 1 plus e power x power 1 over 3. Remember, that has to be raised to the power 5. And then minus 3 over 2. Again, we're saying inside there we have 1 plus e power x power 1 over 3. This has to be raised to power 2. Then plus a constant c. Let's simplify that and get our final solution. So our final solution is 3 over 5. And then I have 1 plus e power x to the power 1/3, and 5 must multiply, 5 over 3, and then minus 3 over 2, and then we have 1 plus e power x to the power 2 over 3, and then I have to say plus c as our constant of integration there. So this is our final solution to integral number 3, which is this one here. Right, this is where I'm going to stop in this video. Like I said at the beginning, if you're new to this channel, please support us by subscribing, sharing these videos with friends. It will help us grow the channel and give us the ability to generate many more videos and support as many students as we possibly can. Provide your feedback. If you have questions, please put your questions in the comment section below, and we can communicate that way. All right, see you in the next one.